Now in this lecture we will find the radius of the circle. In the drawing we have a circle and we have also quadrilateral ABCD is inscribed in this blue circle, and we know that side AB of quadrilateral ABCD equals to 3 units, so we will define side AB as A, that is to say AB equals to A, and therefore A equals to 3 units. We also know that side BC of quadrilateral ABCD equals to 4 units, therefore we will define side BC as B, and B will be equal to 4 units. Side CD of triangle of quadrilateral ABCD equals to 5 units, so we will define CD as C, and C will be equal to 5 units. And we also know that side AD of quadrilateral ABCD equals to 6 units, so we will define AD as D, that is to say AD equals to D, and therefore D will be equal to 6 units. And we actually want to find out the radius of this blue circle. So I will present to you 3 new rules, and we will implement those new rules in our drawing. Rule number 1 is actually the area of quadrilateral ABCD inscribed by a circle equals to so this is the sign of area of quadrilateral ABCD, so it equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C and D are the lengths of sides A, B, C and D are the lengths of quadrilateral ABCD sides. Here A equals to 3, B equals to 4, C equals to 5, and D equals to 6. And S equals to A plus B plus C plus D over 2. So actually, if we have this circle and quadrilateral ABCD is inscribed by this circle. And we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. So according to rule number 1, the area of this quadrilateral ABCD that is inscribed by this blue circle equals to the root of S minus A times S minus B times S minus C times S minus D, and A, B, C, and D are the lengths of this quadrilateral ABC sides. That is to say, side AB equals to A units, side BC equals to B units in its size, side DC equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. And S in this equality equals to A plus B plus C plus D over 2. So if you have any quadrilateral that it is inscribed by a circle, then you can calculate the area of that quadrilateral according to this formula. So actually that is rule number 1, and we also have rule number 2. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products, to the sum of products of its opposite sides. So I will repeat on rule number 2 again. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and this circle, you have quadrilateral ABCD. Quadrilateral ABCD is inscribed by this circle. So this is quadrilateral ABCD. It is inscribed by this blue circle. We also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. And we also know that actually quadrilateral ABCD has two diagonals, diagonal BD and diagonal AC. So I will draw those two diagonals. This is diagonal BD. We will define the size of diagonal BD as x. That is to say, BD equals to x, so the size of BD is x units, and the size of AC, the size of diagonal AC will be defined as y. That is to say, AC equals to y. It equals to y units in its size. And so, according to rule number 2, if you have quadrilateral ABCD, this quadrilateral is inscribed by a circle. So any quadrilateral that it is inscribed by a circle, the product of its diagonals, the product of quadrilateral ABCD diagonals, it is actually x times y. According to rule number 2, this product equals to the sum of products of its opposite sides. Actually, quadrilateral ABCD has two pairs of opposite sides. Side AD is opposite to side BC, and the second pair of opposite sides is side AB is opposite to side CD. So the product of the first pair of opposite sides, it is actually B times D. And the second product of quadrilateral ABCD opposite sides is A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. As I've already said, quadrilateral ABCD has two products of its opposite sides. This is the first product of its opposite sides, and this is the second product of its opposite sides. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, it is actually BD plus AC. Okay, so according to rule number 2, if you have quadrilateral ABCD that is inscribed by a circle, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, that is to say it will be equal to BD plus AC. Okay? So I will repeat again. If quadrilateral ABCD is inscribed by a circle, so we have here quadrilateral ABCD that is inscribed by this blue circle. Then the product of its diagonals, the product of quadrilateral ABCD diagonals is x times y, and that product actually equals to the sum of the products of its opposite sides. And actually quadrilateral ABCD has two pairs of products, two pairs of opposite sides. The first pair of opposite sides is BC is located in the opposite sides of AD. Therefore, the first pair of opposite sides of the first product of the opposite sides is B times D, and the second product of the opposite sides, it is actually A times C, and the sum of the products of the opposite sides, it is actually BD plus AC, and this sum equals to the sum of the products of its diagonals, that is to say x times y or x times y. The product of its diagonals equals to the sum of the products of its opposite sides, equals to BD plus AC. Okay, this is actually rule number 2. And we also have rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. I will read rule number 3 again. Rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So if we have this circle and this circle blocks triangle ABC, that is to say, triangle ABC is inscribed by this circle. So this is triangle ABC that's inscribed by this circle. We also know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. So I will repeat again, this right triangle ABC is inscribed by this circle. Therefore, according to rule number 3, the radius of that circle, the radius of this blue circle that blocks triangle ABC, that is to say capital R, equals to the product of triangle ABC sides. The product of triangle ABC sides is A times B times C over 4 times the area of triangle ABC. Over 4 times the area of triangle ABC. So I repeat again. If triangle ABC is inscribed by a circle, as you can see here, this triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of that circle, the radius of this blue circle that blocks triangle ABC, equals to the product of triangle ABC sides. And the product of triangle ABC sides, it is actually A times B times C over 4 times the area of triangle ABC. Over 4 times the area of triangle ABC. So, if you have any triangle that is inscribed by a circle, then you can find out the radius of that circle that blocks the triangle according to this formula. The radius will be equal to the product of the triangle sides over 4 times the area of the triangle. In our case, the product of triangle ABC sides is actually A times B times C over 4 times the area of triangle ABC. So the radius of this blue circle equals to A times B times C over 4 times the area of this triangle ABC. Okay, this is rule number 3. So we'll actually implement those 3 rules in our original drawing, this drawing. According to rule number 1, the area of this blue quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. Okay? I will repeat again. According to rule number 1, the area of this quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. when A, B, C, and D are the lengths of quadrilateral ABCD sides. In this case, A equals to 3, B equals to 4, C equals to 5, and D equals to 6. And S equals to A plus B plus C plus D over 2. Okay, so if you have a quadrilateral that it is described by a circle, then you can calculate the radius, the area of that quadrilateral by using this formula. S equals to A times B times C. A equals to A plus B plus C plus D over 2. That is to say, S will be equal to the sum of that quadrilateral sides over 2, and A, B, C, and D will be the lengths of that quadrilateral sides. Okay? So that is rule number 1. We will implement also rule number 2 in our drawing. So here we have quadrilateral ABCD that is inscribed with this blue circle. Therefore, according to rule number 2, we'll first of all draw the two diagonals of quadrilateral ABCD. The first diagonal AC, equals to X units in its size, and the second diagonal BD, equals to Y units in its size, and according to rule number 2, if you have any quadrilateral that is inscribed by a circle, like in this drawing, then the product of its diagonals, that is to say X times Y, will be equal to the sum of the products of its opposite sides. The sum of the products of this quadrilateral ABCD opposite sides, it is actually BD plus AC. This is the implementation of rule number 2 in our drawing. So the product of quadrilateral ABCD diagonals is X times Y, and that product equals to the sum of the products of its opposite sides. That is to say, it equals to BD plus AC. So XY equals to BD plus AC according to rule number 2, and we also have rule number 3. According to rule number 3, if a triangle is inscribed by a circle, so we will relate to triangle ABC that is inscribed by this blue circle, then the radius of this blue circle that blocks triangle ABC, that is to say capital R, will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times X, over 4 times the area of triangle ABC. Over 4 times the area of triangle ABC. Okay, this quality number 3 is true according to rule number 3. So here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABX over 4. Here we will divide equation number 3 by R, and we will get that the area of triangle ABC according to equation number 3 equals to ABX over 4R. Actually, we divided equation number 3 by R and we got that the area of triangle ABC equals to ABX over 4R. So in the next step, we'll focus on triangle ADC, this triangle. Actually, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC equals to the product of triangle ADC sides. That is to say, it equals to C times D times X over 4 times the area of triangle ADC. So I will repeat again. If you focus on triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to the product of triangle ADC sides. That is to say, it will be equal to C times D times X, C times D times X over 4 times the area of triangle ADC. Here we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDX over 4. Here we will divide equation number 4 by by R, and we will get that the area of triangle ADC according to equation number 4 equals to CDX over 4R. Okay? So we actually found out the areas of triangles ADC and triangle ABC. Okay? But as you can see from the drawing, if we combine triangle ABC with triangle ADC, we will get quadrilateral ABCD. Again, if we combine triangle ABC with triangle ADC, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. So I will write it down. According to equation number 1, the area of triangle ABC plus the area of triangle ADC will be equal to the area of quadrilateral ABCD. Because of the fact that quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Okay? So the area of quadrilateral ABCD according to equation number 1 equals to the area of triangle ABC, but we've already found out that the area of triangle ABC equals to ABX over 4R plus the area of triangle ADC, but we've already found out that the area of triangle ADC equals to CDX over 4R. So here we will take a common factor of x over 4r out of this equation number 1, and we will get that according to equation number 1, the area of quadrilateral ABCD equals to, so we took x over 4r as a common factor of those two expressions, and what is left inside the brackets after we took x over 4r as a common factor, here what is left is AB, and what is left in this expression after we took x over 4r as a common factor, what is left is actually CD. So we actually found out that the area of quadrilateral ABCD according to equation number 1 equals to x over 4r times AB plus CD. Okay, so in the next step we will focus on triangle BDC. Actually, triangle BDC is inscribed by this blue circle. So actually, the reason the triangle BDC is inscribed by this blue circle is because of the fact that all three vertices of triangle BDC lie on this blue circle. Therefore, for that reason, triangle BDC is inscribed by this blue circle. So, according to equation number 3, according to rule number 3, because of the fact that triangle BDC is inscribed by this blue circle, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times Y over 4 times the area of this triangle BDC. That is according to rule number 3. So I will repeat again, this triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, and the product of triangle BDC sides is B times C times Y over 4 times the area of triangle BDC. So here we will multiply equation number 5 by the area of triangle BDC, and we will get that R times the area of triangle BDC will be equal to BCY over 4 . So we got that R times the area of triangle BDC equals to BCY over 4. Here we will divide equation number 5 by R, and we will get the area of triangle BDC. We will get that the area of triangle BDC, according to equation number 5, equals to BCY over 4R. Okay? So, in the next step, we will focus on triangle ABD. This triangle ABD. So actually, this triangle ABD is inscribed by this blue circle. Therefore, according to rule number 1, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times Y over 4 times the area of triangle ABD. I will repeat again. Because of the fact that triangle ABD is inscribed by this blue circle, then according to rule number 3, the radius of the blue circle will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times D times Y, A times D times Y over 4 times the area of triangle ABD. So here we will multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to ADY over 4. Okay, so we actually multiplied equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADY over 4. Here we will divide the equation number 6 by R, and we will get the area of triangle ABD. We will get that the area of triangle ABD according to equation number 6 equals to ADY over 4R. So we found out the area of triangle ABD, and we have already found out that the area of triangle BDC according to equation number 5 equals to BCY over 4R. But as you can see from the drawing, if you combine triangle BDC with triangle ABD, if you combine those two triangles together, as you can see in the drawing, we will get quadrilateral ABCD. Okay? Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD, because of the fact that quadrilateral ABCD consists of those two triangles, triangle BDC and triangle ABD. So I will write it down that the area of quadrilateral ABCD according to equation number 2 equals to the area of triangle ABD plus the area of triangle BDC. Okay, so the area of quadrilateral ABCD according to equation number 2 equals to the area of triangle ABD But we already found out that the area of triangle ABD equals to ADY over 4R plus the area of triangle BDC. We've already found out that the area of triangle BDC equals to BCY over 4R. So here we take a common factor y over 4R out of these expressions, and we will get that the area of quadrilateral ABCD according to equation number 2 equals to y over 4R is a common factor, and what is left inside the brackets after we took y over 4R as a common factor, inside the brackets we will have in this expression what is left is AD, and what is left in this expression after we took out y over 4R as a common factor is actually BC. So in total, we got that the area of quadrilateral ABCD, according to equation number 2, equals to y over 4R times AB plus CD, okay? So we found out that according to equation number 2, the area of quadrilateral ABCD equals to y over 4R times AD plus BC. But we have already found out that the area of quadrilateral ABCD, according to equation 1, the area of quadrilateral ABCD equals to x over 4R times AB plus CD. So here we have two different expressions for the area of quadrilateral ABCD. So we will multiply equation number 1 by equation number 2, and we will get equation number 3, that is the area of quadrilateral ABCD squared so it equals to x times y over 4R squared times AD plus BC times AB plus CD. Okay, so here we will take a root out of equation number 3, and we will get that the area of quadrilateral ABCD equals to the root of the numerator. It is actually the root of x times y times AD plus BC times AB plus CD over, so here the root of 4R squared is 4R because of the fact that the square the root cancels the square, so what is left is 4r. Okay, so here we will multiply equation number 3 by r, and then we will divide it by the r of quadrilateral ABCD. So first of all, we will multiply equation number 3 by r, and we will get that r times the area of quadrilateral ABCD equals to the root of xy times AD plus BC times AB plus CD over 4. So here we will divide equation number 3 by the area of quadrilateral ABCD, and we will get the radius r that we are looking for. Okay, we will get that after we divide the equation number 3 by the area of quadrilateral ABCD, we will get that the radius that we are looking for equals to the root of xy AD plus BC times AB plus CD over 4 times the area of quadrilateral ABCD. So we divided equation number 3 by the area of quadrilateral ABCD, and this is the expression that we got. So here we have x times y inside the root, but we know that x times y according to rule number 2 equals to AC plus BD. I will write it down. According to rule number 2, x times y equals to AC plus BD. Therefore, we can substitute x, y in equation number 3 by AC plus BD. So we'll do it now. We will get that the radius that we are looking for will be equal to the root of, so instead of xy, we will write down AC plus BD times AD plus BC times AB plus CD over 4 times the area of quadrilateral ABCD. Actually, we know the values of all the variables inside equation number 3. The only thing that is missing is the area of quadrilateral ABCD. We have already found out the area of quadrilateral ABCD, but I will repeat on the same process. We get that the radius that we are looking for equals to actually, first of all, we will find out the area of quadrilateral ABCD. According to equation number 1, the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. A, B, C, and D are the lengths of quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2 we know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So therefore S will be equal to A is 3, B is 4, C is 5, and D is 6 over 2. So 3 plus 4 is 7, 7 plus 5 is 12, and 12 plus 6 is 18, 18 over 2 is 9. So we found out that S equals to 9 units, and so here we will substitute S in this equality by 9, and we will get that the area of quadrilateral ABCD will be equal to the root of S minus A. S is 9, A is 3, so it is S minus A is 9 minus 3 times S minus B. S is 9, B is 4, so it is 9 minus 4. S minus C, S is 9, C is 5, so it is 9 minus 5. And S minus D, S is 9, D is 6, so it is 9 minus 6, S minus D is 9 minus 6. So we got this expression for the area of quadrilateral ABCD. It is very easy to find out the area of quadrilateral ABCD. Only to do the simple arithmetic. What is left? It will be equal to the root of 9 minus 3 is 6, and 9 minus 4 is 5, and 9 minus 5 is 4, and 9 minus 6 is 3. So the area of quadrilateral ABCD will be equal to the root of 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So we actually can substitute here the area of quadrilateral ABCD in equation number 3 by the root of 360 square units that we found out. So we'll do it now. We will get that the radius that we are looking for, according to equation number 3, equals to the root of AC plus BD times AD plus BC times AB plus CD. All divided by 4 times the area of quadrilateral ABCD. We already found out that the area of quadrilateral ABCD equals to the root of 360 square units. So we write it here, and all is divided by 4. So actually we found out that the radius that we are looking for equals to this expression, and the only thing that is left to do is to substitute the values A, B, C, and D by the values that are given in the question. So I write it here, the values of A, B, C, and D. And we will put the data inside this equation number 3, and we will find out the radius of the circle that we are looking for, and we know that it is given us the question that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So, according to equation number 3, the radius equals to the root of AC. A is 3, C is 5, so AC is 3 times 5 is 15, plus BD. B is 4, D is 6, so BD is 4 times 6 is 24, plus AD. A is 3, D is 6, 3 times 6 is 18, plus BC. B is 5, B is 4, C is 5, so 4 times 5 is 20, times AB. A is 3, B is 4, 3 times 4 is 12, plus CD. C is 5, D is 6, 5 times 6 is 30, and all divided by 360 divided by 4. So R equals to, according to equation number 3, R, the radius that we are looking for, equals to the root of 15 plus 24 is 39, 18 plus 20 is 38, and 12 plus 30 is 42, divided by 360 over 4. Okay, so here the root of 39 times 38 times 42 over 360 equals to 172.9. Okay, so R equals to the root of 172.9 over 4. So we actually found out that the radius of this circle equals to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, so I repeat again, the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. That is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. This blue circle blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by this circle. We know that side AB of quadrilateral ABCD equals to 3 units. So we define side AB as A, and A equals to 3 units. We also know that BC equals to 4 units, so we defined BC as 4, that is to say we define BC as B, that is to say BC equals to B, and therefore B equals to 4 units. And side CD of quadrilateral ABCD equals to 5 units, therefore we define side CD as C, that is to say CD equals to C, and therefore C equals to 5 units. And we also know that side AD of quadrilateral ABCD equals to 6 units, therefore we defined side AD as D, that is to say AD equals to D, and therefore D equals to 6 units. And we want to find out the radius of this blue circle. that blocks quadrilateral ABCD. Okay, so I actually presented to you 3 new rules, and we implemented those 3 new rules in our drawing. Rule number 1 states that the area of quadrilateral ABCD inscribed by a circle equals to, this is the sign of the area of quadrilateral ABCD, it equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of these quadrilateral ABCD sides. That is to say, the size of side AB is A units, the size of side BC is B units, and the size of side CD is C units, and the size of AD is D units, and S equals to A plus B plus C plus D over 2. Okay, so whenever you have quadrilateral that is inscribed by circle, like in this drawing, you can calculate the area of that quadrilateral according to this equation, according to this formula, when A, B, C, and D are the lengths of the quadrilateral sides, and S equals to A plus B plus C plus D over 2. This is rule number 1, and we also add rule number 2. According to rule number 2, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So if we have quadrilateral ABCD, that could be any quadrilateral, and this quadrilateral is inscribed by a circle. In this drawing, quadrilateral ABCD is inscribed by this blue circle. So if it is the reality, only if the quadrilateral is inscribed by a circle, we can implement rule number 2. And according to rule number 2, the product of its diagonals, quadrilateral ABCD, has 2 diagonals, diagonal BD and diagonal AC. We defined the size of diagonal BD as x, and we defined the size of diagonal AC as y. And according to rule number 2, the product of its diagonals, that is to say x times y, is the product of its diagonals, equals to the sum of the squares, to the sum of the products of its opposite sides, equals to the sum of the products of its opposite sides. Actually, quadrilateral ABCD has 2 pairs of opposite sides. The first pair of opposite sides is side BC is opposite to side AD, and we know that BD equals to BC equals to B units in its size, and AD equals to D units in its size, and therefore B times D is the first product of its opposite sides. And they also have a second pair of opposite sides. Side AB is opposite to side CD, and the size of side AB of quadrilateral ABCD is A units, and the size of side CD of quadrilateral ABCD is C units, and the product of those opposite sides is A times C. So we have 2 products of the opposite sides. The first product of the first pair of opposite sides is B times D, and the second product of the opposite sides is A times C. And according to rule number 2, the sum of the products of the opposite sides equals to xy. That is to say, BD plus AC, that is the sum of the products of the opposite sides, equals to the product of its diagonals, equals to x times y, that is the product of its diagonals. Okay, I will repeat again on rule number 2. If we have a quadrilateral ABCD that is inscribed by a circle, like in this drawing, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. Equals to the sum of the products of its opposite sides, that is to say, it equals to BD plus AC. Okay? So that is rule number 2, and we have also rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So if we have triangle ABC that is inscribed by a circle, like in this drawing, then we can implement rule number 3, and rule number 3 states that the radius of this circle that blocks the triangle ABC in our case will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times C over 4 times the area of triangle ABC. Okay, so if you have a triangle that is inscribed by a circle, then you can calculate the radius of the circle that blocks the triangle. According to rule number 3, it will be equal to the product of the triangle's sides, that is to say, in this case is A times B times C over 4 times the area of this triangle, over 4 times the area of triangle ABC. Okay? So that is rule number 3. And we actually implemented all those 3 rules in our drawing. This is the original drawing of the question. According to rule number 1, the area of this quadrilateral ABCD that is inscribed by this blue circle equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides. In this case, A equals to 3, B equals to 4, C equals to 5, and D equals to 6 units. And S equals to A plus B plus C plus D over 2. Okay, that is rule number 1, and we also implemented rule number 2 in our drawing. According to rule number 2, if we have quadrilateral ABC D that is inscribed by a circle like in this drawing, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. That is to say, it will be equal to BD plus AC. Okay, xy equals to BD plus AC, according to rule number 2. And we also implemented rule number 3 in our drawing. If we relate to triangle ABC, this triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides. That is to say, it will be equal to A times B times X, A times B times X over 4 times the area of triangle ABC that is inscribed inside the circle. That is according to rule number 3. Here we multiplied equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABX over 4. Then we divided equation number 3 by R, and we got that the area of triangle ABC equals to the area of triangle ABC equals to ABX over 4R. So then we related to triangle ADC. As you can see from the drawing, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides. That is to say, it will be equal to C times D times X. The radius will be equal to C times D times X over 4 times the area of triangle ADC. So here we will multiply according to rule number 3, of course. We multiplied equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDX over 4. Here we divided the equation number 4 by r, and we got that the area of triangle ADC equals to CDX over 4r. So we got the areas of triangle ABC and triangle ADC. But as you can see from the drawing, if we combine triangle ABC with triangle ADC, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Again, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists of those two triangles. But we have already found out that the area of triangle ABC is ABX over 4R, and the area of triangle ADC is CDX over 4R. So here we got, we took out the common factor of those, from those two expressions, a common factor of x over 4R, and we got this expression that the area of quadrilateral ABCD equals to x over 4R times AB plus CD. Then we related to triangle BDC. This triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say B times C times Y. The radius of the circle will be equal to B times C times Y over 4 times the area of triangle BDC that is inscribed by this blue circle. According to rule number 3, we multiply the equation number 5 by the area of triangle BDC, and we got that R times the area of triangle BDC equals to BCY over 4. Here we divided the equation number 5 by R, and we got that the area of triangle BDC equals to BCY over 4R. Then we related to triangle ABD. This triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times D times Y. A times D times Y over 4 times the area of triangle ABD, according to rule number 3. Here we multiplied equation number 6 by the area of triangle ABD, and we got that the radius times the area of triangle ABD equals to ABY over 4. Okay, here we divided equation number 6 by R, and we got that the area of triangle ABD equals to ADY over 4R. And we already found out that the area of triangle BDC equals to BCY over 4R. And as you can see from the drawing, if we combine triangle BDC with triangle ADB, if we combine those triangles together, we will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. Very simple. The area of triangle ABCD, according to equation number 2, will be equal to the area of triangle ABD plus the area of triangle BDC. But we have already found out that the area of triangle ABD equals to ABY over 4R, and the area of triangle BDC equals to BCY over 4R. Here we took a common factor of y over 4R out of those two expressions, and we got that the area of triangle ABD equals to y over 4R times AB plus BC. AB plus BC. But we have already found out the equation, according to equation number 1, that the area of quadrilateral ABCD equals to x over 4R times AB plus CD. So we have two different expressions for the area of quadrilateral ABCD. And we multiplied equation number 1 by equation number 2, and we got equation number 3, that is the area of quadrilateral ABCD squared. It equals to xy times AB plus CD times AB plus CD. over 4r squared. Then we took out a root out of this equation number 3, and we got that the area of quadrilateral ABCD equals to the root of the numerator, and the root of 4r squared is 4r, because the root cancels the square, and what is left is 4r. Here we multiply the equation number 3 by r, and we got that r times the area of quadrilateral ABCD equals to the root of this expression over 4. Here we divided the equation number 3 by r, and we got that the area of quadrilateral ABCD according to equation number 3 equals to this expression. And we know that x times y equals to AC plus BD according to rule number 2. Therefore, we can substitute xy in equation number 3 by AC plus BD, that equals to xy. So we did it here, and we got this expression. And so the only thing that is left here is to find out the area of quadrilateral ABCD, because all the other variables are known. It is given us in the question. We have already found out the area of triangle of quadrilateral ABCD, but I repeat it on the same process again. The area of quadrilateral ABCD equals to the root of s times s minus a times s minus b times s minus c times s minus d, when A, B, C, and D are the lengths of quadrilateral ABC sides. A equals to 3, B equals to 4, C equals to 5, and D equals to 6 units. And S equals to A plus B plus C plus D over 2. Therefore, we can easily find out the value of S, because A is 3, B is 4, C is 5, and D is 6. So 3 plus 4 plus 5 plus 6 over 2 is 9. So we found out that S equals to 9 units. So we can substitute S in this equality by 9, because S equals to 9. And we know all the other variables. Okay? So the area of quadrilateral ABCD will be equal to the root of 9 minus 3 times 9 minus 4 times 9 minus 5 times 9 minus 6. Here A, B, C, and D are 3, 4, 5, and 6. So that are those numbers. So 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, 9 minus 6 is 3. And so these are the numbers. 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So we can substitute here ABCD in this equality by the root of 360, because the area of quadrilateral ABCD equals to the root of 360 square units. So we substituted ABCD, the area of quadrilateral ABCD by the root of 360 square units, and we got this expression. So here actually we have all the variables inside this equation number 3, and the only thing that is left is to put the data inside this equality number 3, and we will find out the radius that we are looking for. A is 3, C is 5, so AC is 3 times 5 is 15. B is 4, D is 6, so 4 times 6 is 24. A is 3, D is 6, so 3 times 6 is 18. B is 4, C is 5, so 4 times 5 is 20. And here A is 3, B is 4, so 3 times 4 is 12. Here we have CD, C is 5, D is 6, so 6 times 5 is 30, and all divided by 360 over 4. 15 plus 24 is 39, 12 plus 20 is 38, and 12 plus 30 is 42. And actually 39 times 38 times 42 over 360, it is actually equals to the root of 172.9 over 4 units. So we found out that the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle that blocks quadrilateral ABCD, in terms of numbers, it equals to 3.287 units. I'll repeat again. The radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.